So today we're going to talk a little bit about just pulleys as a simple machine. Okay, a pulley is nothing but a lever made up of a wheel that has a groove in it. Okay, and then you use a cable or a rope or chain to change the direction and the magnitude of the force. And there are pulleys utilized in a variety of applications. All right. So a fixed pulley, okay, the pulley would be mounted, all right, and so the pulley itself doesn't move. It's really just a first-class lever. And you can see I've kind of drawn the fulcrum in there on that picture. It has a mechanical advantage of 1. So from a mechanical point of view, there's no advantage, but it does make it easier to use it because it changes the direction of the force. For instance, it's easier to pull down on that rope with 10 pounds of force than it is, in some cases, to squat and lift up the 10 pounds of weight. Right? A movable pulley has an ideal mechanical advantage of 2. All right? So the direction of the force is still the same. All right? But it gives you a mechanical advantage of 2, so you only need 5 pounds of force to lift the 10-pound weight. It's a second-class lever, and you can see I've drawn the lever in there on that pulley. Alright, pulleys in combination. You can have a combination of fixed and movable pulleys to give you changes in direction, more mechanical advantage, those kinds of things. Okay, so if you have a combination like this, alright, what you would want to do, this is called a block and tackle. What you would want to do is find the mechanical advantage of this system. So you'll count the strands that are on that pulley system. Alright, so I'm going to count. I see 1, 2, 3, 4, 5 strands. Okay, except the 5th strand, the one with the little arrow at the bottom, is the one I would hold in my hand. Okay, and so I don't count that one in the mechanical advantage. So 5 minus 1, that's 4. Alright, so the mechanical advantage is 4. So to lift that 800-pound weight, we would need to apply a force, an effort force of 200 pounds. Alright, if we have a combination of all movable pulleys, alright, so each time the mechanical advantage is 2. So basically what we do is we count the movable pulleys and we keep multiplying by 2. So there are 1, 2, 3 multiple movable pulleys. So we multiply them. 2 times 2 is 4 times another 2 is 8. So the mechanical advantage of this system is 8. And so we only need 10 pounds force to lift the 80 pounds. Alright? Okay. Actual mechanical advantage is the ratio of the actual forces involved. Alright? Because the mechanical advantage, when we just count strands or divide by 2 for movable, multiply by 2 over and over for movable pulley systems, doesn't take into account things like friction, air resistance, those kinds of losses. So if we look at this, and I was given that I was lifting an 800-pound weight, right, but it required 230 pounds to do it, right, I could calculate the actual mechanical advantage. Now remember, the ideal mechanical advantage of this system, we counted the number of strands, except the one we were holding, it was 4. That's the ideal mechanical advantage. But when I take into account losses for friction, I actually get 3.48 is the actual mechanical advantage. Alright, so efficiency is a ratio of the actual mechanical advantage to the ideal mechanical advantage. We normally report it in percents, okay? And it tells us, it takes into account things like friction, air resistance, losses due to changes in forms of energy, those kinds of things, and it is the actual mechanical advantage divided by the ideal mechanical advantage. Alright, so the best this could be in a perfect world would be 1 or 100%. Okay, that's not going to happen unless there's something you're not accounting for. Alright, so when I take the actual mechanical advantage, we got on the last page, 3.47, and I divide by 4, that was the ideal, 4 strands, okay, I get a decimal and it rounds off to be 87%. Alright, so that's the efficiency.